Hello friends, in this video I am going to deal with the top 10 conceptual ideas from permutations and combinations which are very helpful for JEE mains, right? So among those, the first conceptual idea is the counting principles as well as the definitions of permutations and combinations. See, counting principles. Basically, we have two counting principles. One is the counting principle of addition and the other one is the counting principle of multiplication. We are very familiar with the addition and multiplication, but what is counting principle of addition and multiplication? See, whereas coming for the counting principle of addition, there are different situations where we are utilizing the concept of addition and the concept of multiplication as per the situation, and if we are able to decide which one is helpful to solve the problem, then it automatically resolves the problem, right? See, for example, I am going to give an example for the counting principle of addition. For suppose if I have 3 black shirts as well as 4 white shirts. If I have 3 black shirts and 4 white shirts, in how many ways I will get ready? See, usually I will wear only one shirt. So I have 3 black shirts and 4 white shirts. The number of ways to get ready is nothing but 7, because we need to select any one among those 3 or these 4. So the number of ways are 7. Here we use the counting principle of addition. Whereas coming for the multiplication, see, we know that multiplication is the repeated addition. See, with this basic definition of the multiplication as the repeated addition, we will face different situations related to this. For example, if I have 3 black shirts and then 4 trousers, for example, 3 black shirts and then 4 white trousers. See, these are the 3 black shirts and then I have 4 white trousers. Then in how many ways I will get ready with these black shirts and then white trousers? See, we have 3 black shirts and 4 white trousers. So for every black shirt, we have 4 chances to select a trouser. See, for the first shirt, I have 4 chances. Second one, 4 chances. Third one, 4 chances. So the number of ways to get ready with these is 3 into 4, 12. So this is the situation where we are using the counting principle of multiplication. See, that is the situation where we are using counting principle of addition. Okay. See, these are the simple logics, but if you are in a situation to decide which one is helpful, whether addition or multiplication, that common sense is usually solve many problems, right? This counting principle of multiplication is then developed as the concept of permutation. If we are strong at this counting principle of multiplication, then permutations are very easy for us, right? See, one coming for the permutations. Permutations is nothing but usually arrangements. Permutations means arrangements, whereas combinations means selections. See, situations where we are going to arrange the given objects, we need to use permutations. And among the situations where we are going to use selection of objects, then we have to use combinations. For suppose, if I have 5 objects like A, B, C, D, E, among these 5 objects, if I wish to arrange 3 objects, then how can we arrange? See, I have 5 objects A, B, C, D, E. Among these 5 objects, I need to arrange 3. So, arrangement of 3 out of 5. 3 out of 5. What is the 3? Arrangements or permutations. Arrangements of 3 out of 5. So, since I need to arrange 3 out of 5, so I need to fill 3 places using those 5 objects. Since I have 5 objects, this first place has 5 chances to fill, second place has 4 chances because already one object is filled, and then this third place have 3 chances to fill. The total number of arrangements are 5 into 4 into 3. And this is first place has 5 chances, second place has 4 chances, third place has 3 chances, and the total number of chances are 5 into 4 into 3 by the counting principle of multiplication. See, this 5 into 4 into 3 later denoted as 5p3, arrangement of 3 objects out of 5. Okay, and that 5p3 is usually calculated using the rule that 5 factorial by 2 factorial, because 5 factorial is 5 to 1, whereas 3 factorial is 3 to 1. Both will get 2 factorial is 2 to 1, and then will get cancelled. You have to take 5 into 4 into 3. So if you directly use the counting principle of multiplication, then most probably no need to use this rule of permutation. And if you are strong by using the rule of permutation, then comfortable. Okay, so as per the problem, as per the situation, you need to decide which one is useful, either counting principle of multiplication or the concept of permutation, right? So arrangement of 3 objects out of 5, permutations of 3 objects out of 5 is nothing but 5 into 4 into 3, which is 5p3, and that is 5 factorial by 2 factorial. See, with this idea, the notation for the permutation is developed. And finally, NPR. What is NPR? Permutations of R objects out of N, or arrangements of R objects out of N, and which is defined as, calculated and formulated as n factorial by n minus r factorial. NPR is n factorial by n minus r factorial. And while calculation, for example, if you have the 10p4, which is nothing but 10 factorial by 10 minus 4 factorial, or directly you write just 4 terms starting from the 9, 10 into 9 into 8 into 7, which directly gives us the value of 10p4, or you may use that formula also. So NPR is the permutations of R objects out of N objects, right? Or nothing but arrangements. And then when we have to arrange no objects, what is NP0? Since we are arranging no object out of N, its value is 1. And when we are arranging all the objects, NPN, which is nothing but n factorial. So for example, if I have 7 objects, in how many ways we need to arrange those 7 objects among themselves? That means we need to frame different arrangements with those 7 objects. So then the total number of arrangements are 7 factorial. So this is the definition of the permutation. Whereas coming for the concept of combination, combinations are nothing but selections. See, the number of combinations of R objects out of N. See here, like NPR, here we will replace NCR. This NCR is nothing but number of ways of selecting R objects out of N. Number of combinations or number of selections of R objects out of N. See, once if you look, already among the permutations, already selections are involved. See, for example, if I have 3 objects like A, B, C. What are the number of arrangements? Arrangements of 2. If I say 3p2, arrangements of 2 out of 3. If I write arrangements of 2 out of 3, how many I will get? AB, BA, AC, CA, BC, CB. These are the arrangements of 2 out of 3. But if you look among those, these 2 arrangements will look like one selection. These 2, one selection. These 2, one selection. Later on, by observing different examples like that, we will confirm that every 2 factorial of these total arrangements looks like one selection. From that, we will confirm that every R factorial arrangements give us one selection. Since every R factorial arrangements of the NPR gives one selection, we will formulate that NCR as NPR by R factorial. And finally, the value of NCR is NPR by R factorial. Here we need to memorize 3 things. One thing is the notation, other one is the definition, third one is the formula. The notation is NCR, and the definition, the meaning of that NCR is the selection of R objects out of N, and it is formulated as NPR by R factorial. And later on, if you simplify, you will get it as N factorial by R factorial into N minus R factorial. NPR is this one, NCR is that one. Like that, like 10p4, if you wish to calculate 10c4, number of ways of selecting 4 objects out of 10. See, you need to use that formula, or otherwise you just directly write 4 terms in the numerator like 10 into 9 into 8 into 7, and 4 terms in the denominator like 4 into 3 into 2 into 1. If you simplify this value, you will get the value of 10c4, right? And as we discussed, like here, for NCR, for example, if you try to write NC0, NC0 means selection of 0 objects out of N. NCN means selection of all objects out of N. For example, if I have N objects, no object is selected, and the number of chances is 1. Selection of nothing. If I have N objects, if all the objects are selected, so the number of selections is 1. Selection of all the objects. So from there we will confirm that NC0 is equals to NCN is equals to 1. And in the same manner, NC1 is equals to, NC1 means selection of one object out of N. I have N objects, I need to select one object, then NC1 will give us N. Okay, so these are the basic ideas, and from this NCR is equals to NPR by R factorial, and from this arrangements, one very useful logic which we need to memorize is there is a direct relation between the arrangements as well as the combinations. See, after see, the basic definition between those two is nothing but, say, look here, number of arrangements of R objects is equals to number of selection of R objects into R factorial. See, for example, we may face different types of problems. So first of all, you need to decide after observing the problem whether the problem is corresponds to the arrangement or corresponds to the selection. That basic difference, that basic decision is very important in solving the problems. If the problem is related to the arrangements, you go with the permutation. If the problem is related to the combination, you go with the selections, you go with the combinations. And the relation between those permutations and then combinations, that means arrangements and the selections, it will be like this. Number of arrangements